So now we will take one example, numerical example on the principle of superimposition. So this is the given structure. Here the diameter is 25 mm and here the diameter is 50 mm and here this is 30 mm. Okay, and here only three values are known: f1, okay, f3 and f4. So we need to find out remaining force f, what is that, f2 and elongation. Okay, how to find out the f2? We will use the principle of equilibrium. So at equilibrium, sigma f equal to 0, and here in this case we have forces only in the horizontal direction. When the forces are only in the horizontal direction, then you equate it. So what are the forces that are facing the leftward? Those are f1 plus f3. Okay, and what are the forces that are facing the rightward side? That is f2 plus f4. Okay, see, in all the derivations we use this basic formulas. What are that? The summation of the forces and then the moment of inertia. We use these two, and from that we will calculate the remaining. So we need to find out the f2. What is the f1 plus f3? f1 is 10 and f3 is 40, so that is a 50 minus f4. f4 is a 16. Okay, then it will become 34 kilonewton. Okay, f1 become 34 kilonewton, and then we have given the area of each bar. So this is a 25 mm. This is a circular cross section. So if I calculate the area for this, then it will come 490.9 mm square. And for this section, if I calculate the area, then we will get A2 equal to 1963.5 mm square. So I have already calculated that and kept there. And we will take now, one by one. For the calculation of elongation, we will take the section one by one. Okay, first I will take the section, this, let's say this is the section 1. Okay, so this is the section 1, and for the force balance, on the left hand side, what are the forces that are acting? Only f1. On the right hand side, what are the forces that are acting? So that is the summation. So f2, so here I will write f2 equal to 34. So what is the value of f2? f2 is 34, which is acting in the rightward side. f2 minus f3. Minus f3 is 40 plus f4. f4 is nothing but 16. Okay, then it will become 10. Okay, it will become 10, and here also it will become 10. And what is the length? That is 1000 mm. This length is 1000 mm. Then delta 1 in this case is f into L divided by A into E. Okay, and if you substitute these values, then f is the, what is the value of f here? F is 10 into 10 power 3, because this is a kilonewton, and the length is mm. This is mm. If I write in terms of meter, then it will become 1 divided by area. Area is 490.9 into 10 power minus 6, because this is in the mm square. So if I convert into meters, then it would be in the 10 power minus 6. We see, you always remember that the uniformity of units. And E is given as a 2.05 into 10 power 5 Newton per mm square. So 2.05 into 10 power 5, and this is a Newton per mm square, and if I write mm square in terms of meter, then it will become 10 power 6. It will come to top. Okay, then what is its value? Delta 1 value is 0. See, this will become, see here in this case, the value will come in the meters. 0.00 mm meter into 10 power minus 3 meter. Okay, then if you convert this into mm, then you lose this to 10 power minus 3. Okay, this is the value for this. And now I will take the section 2. Okay, I will write this value here. This is the 0.099 mm. Okay, this is the 99 mm. Now I will take the second portion. This is the second portion. In the second portion, we have on the left hand side we have f1 minus f2. Okay, value of f2 we found out. So f2 is f1 is how much? 10 minus f2. f2 is 34. It is equal to minus 24. Okay, so the sign is reversed. That means it is compressed. See, this is a compressing. Okay, and then here on the right hand side, what are the forces that are acting? F4 is 16 and F3 is acting in the opposite direction, that is 40. Okay, that means minus 24. Again this sign is reversed, so here compressive. So in this case this is a compressive and its length is 600 mm. Okay, and area also given A2 1963. Then we need to find out delta 2. Okay, delta 2 equal to, this is a compressive, so I will substitute minus value. 24 into 10 power 3, length is 0.6 if I write in the meters. Okay, then area is 1963 for this particular portion. 1963.5 into 10 power minus 6 if you convert into the meters. Okay, and what is the value of E? That is a 2.05 into 10 power 5 into 10 power 6 if you write this in terms of Newton per m square. So after simplification you will get minus 0.0358 mm. Okay, this is the mm. Now I will take the third portion. Okay, this is the third portion. And in the third portion on the right hand side only F4 is acting. What is the value of F4? That is only 16. And on the left hand side, what are the forces that are acting? F1 is acting in the left side. Okay, that is the 10, and F3 also acting in the left hand side, that is 40, and here F2 is acting in the right hand direction, that is minus 34. So this will become 16. Okay, and what is the length of this? This is 800 mm. Okay, this is 800 mm and this is also 800 mm. So this is 600, this is 800. Then delta 3 equal to, here this is a tensile. Okay, so whatever value is there we will keep that positive. And F is 16 into 10 power 3 into L is 0.8 if you write in terms of the meter. And what is the area? Area is 706.858 into 10 power minus 6. And what is the value of E, Young's modulus? That is 2.05 into 10 power 5 into 10 power 6. Okay, after simplification you will get 0.088 millimeters, and by using the principle of superimposition we can find out the delta. So delta equal to delta 1 plus delta 2 plus delta 3. Okay, the total deformation. So delta 1 is 0.099 and delta 2 is minus 0.0358 plus 0.088. Okay, so after simplification you will get 0.151 mm. Okay, this is the final deformation for this body. So whenever the problem is given like this, we need to carry like this. Okay, and next, if the structure is like this, see this is a hanging, and in the hanging we at different cross sections I applied again some forces, here F1 and here F2 and here F3. Okay, because of these forces there is a reactionary force at the support. That reactionary force is nothing but R here, and here again the same procedure. So what is the delta here? Delta is delta 1 plus delta 2 plus delta 3, and but here First we need to find out the R, reactionary forces. Okay, if you neglect these, then it would be there would be some problem in the calculations. Okay, even we cannot neglect this. Why? Because if you take individual one, then if you consider F1, then there has to be some other force in the opposite direction. So first here find R, and then by using this, if you consider individual sections, then you can find out the individual deformation. After finding the individual deformation by summing up all, then you will get the final deformation. This is as like in the previous case. Okay, and in the next problem we have a hollow cylinder like this. In the hollow cylinder, the forces are acting from the both ends. When the forces are acting in the both ends, we need to find out, and here the ultimate stress for this particular material also mentioned here. Ultimate stress is also mentioned, and for the given ultimate stress we need to find out the diameter, outer diameter of this particular cylinder. Okay, and here factor of safety also given. So when the factor of safety is given, then we need to find out the allowable stress. What is the allowable stress? Allowable stress equal to maximum stress, or in this case this is the ultimate stress divided by factor of safety. So this is a 240 divided by 3, then it will become how much? So it will become 80. This is a 80 megapascal. Okay, and here force also given, and sigma allowable also given, and we need to find out the diameter. So what is the relation between these two? Stress equal to force by area. Okay, by using that relation, and in the area, what is the equation? Area equal to pi by 4 into d square minus whatever it is there. Okay, so by using that equation we can find out, and here we also know the thickness of the cylinder. Okay, so and here how can we equate that? Why? Because if you consider only F as the maximum at this particular instance, then only we can equate. Okay, when the force is maximum, then only we can equate like this. Allowable, sigma allowable equal to F max by A. So in this case we assume that whatever force applied on this cylinder is F max. Okay, F max, because this is the maximum allowable value. So whenever the force is maximum, then only it will equal to the allowable stress here. Okay, and here A equal to F max divided by F sigma allowable, and what is the force here? That is a 352 divided by 80, and what is the value of this? And this value is 4400 mm square. This is the value that we got there. Okay, and what is the area from that calculation? Area equal to pi by 4 into d square, outer diameter. I am considering outer diameter as the d here. Then outer diameter equal to d square minus, we need to subtract this particular area. Okay, we need to subtract excuse me, we need to subtract this particular area. And how to do that? That is nothing but here, that is nothing but from the total diameter we need to take this thickness and again this thickness. Okay, how many times we need to subtract? 2 times, this thickness and then this thickness. So this is a 2t, okay, whole square. And if I expand this, then it will become pi by 4 into d square minus d square. This is a minus b whole square. So a square plus b square minus 2ab, and we have a minus value before that. So it will become d square minus 4t square. Okay, and then this is a plus 2dt. Okay, this is the value, and here further it will become pi by 4 into, if I take this t outside, then it will become, and I can take here, this is also 4. Okay, then if I take 4 also outside, then it will become d minus t. d minus t. Then it will become pi t by pi t into d minus t. Okay, this is the value. So I will equate that value to this particular value. Okay, then pi into 28 into d minus 28 equal to 4400. Okay, what is the pi? Pi can be written as a 22 by 7. Okay, this is a 4 times, and this is a 2 times 200, and this is a 4 is a how many times? 5 times 50. Okay, then it will become d equal to 50 plus 28. See, UPSC generally may give these type of problems where the simplification will be easier without the calci. So if it is not, then it is our bad luck. Then this is a 78 mm. Okay, what is the outer diameter size? That is a 78 mm. We need to calculate like this. Okay, even if you need to calculate, and even if you don't know that the applied force is a F max, then you blindly use this equation, you use this relation. Why? Because there is no other go, without using this we cannot find out the value of the d. So you assume that and you proceed like that. Okay,
for engineering services general studies video lectures, visit www.iesgeneralstudies.com. For mechanical engineering video lectures and question and answer discussion, visit www.getnet.com.